Okay, 2012 AMC. This is problem 15 from the AMC12B and 17 from the AMC10B. And it looks to be a lot easier than problem 14 was, so that'll be nice. Jesse cuts a circular paper disc of radius 12 along two radii to form two sectors. The smaller having a central angle of 120 degrees, he makes two circular cones using each sector to form the lateral surface of a cone. What is the ratio of the volume of the smaller cone to that of the larger? So here we go. What we have is we have a circle, and Jesse cuts out a sector, 120 degrees. And what this means for us, so if this radius is 12, that means the diameter is 24, and so the area all the way around is 24 pi. This is 1/3 of the cone, or of the circle, because the entire circle around is 360, so this is 240 degrees. And if this is 1/3, the arc length here will be 1/3 of 24 pi, which is 8 pi, and we're going to use that. Okay, the arc length over here is going to be the remaining 2/3 of the arc, or of the circle, which is going to be 16 pi. Okay, and now we have two cones. So I have this cone, I'll deal with the, let's see, the ratio of the smaller cone to that large. So let me do the smaller cone first. So we have this one cone with a circumference around the base that is, so let's say circumference is equal to 8 pi. And a lateral height here, that's going to be, let's see, 12. And what that means for you now, to find the volume of a cone, I need the radius of the cone, and I need the height of the cone. The radius I know, if this is 8 pi, the diameter is 8, so the radius is 4. And then by doing a little bit of Pythagorean theorem, I can find this. This is a right angle down here. So I have hypotenuse 12, one leg of 4, I need to find this other leg. So I'll just do it. So we'll call this h squared is equal to, worst Pythagorean theorem. All right, h squared plus 16 is equal to 144. Subtract 16 from both sides, and I get h squared is equal to 128, which is a big old multiple of 2. So we're going to take a square root, no plus or minus here because we're talking about a height. So h will equal, let's see, what's the biggest power of 2 that goes in there? 16 is too big, but 8 times 8 is 64, so, and that's half of that, so we have 8 root 2 for this height. And that means that this volume, this blue cone volume, is going to be pi r squared h. That's the formula for this. R is 4, h is 8 root 2, so we have pi, 4 squared is 16, h is 8 root 2, and 8 times 16, we just sort of saw, is going to be 128. So 128 pi times the square root of 2. We'll do the same thing for this purple cone, which is going to be a little bit wider. Same arguments all the way through, so I'm going to go a little bit faster here. We have a circumference of 16 pi. And a lateral length here of 12. We're going to find this radius and this height. This is 8. That's I'll call it h just so I don't need to write subscripts on there, but it's a different h than this h, of course. So we have h squared plus 64 is equal to 144. Subtract 64 to get that h squared is equal to 80. 16 goes into 85 times, so h is equal to 4 root 5, and we use this to find the volume of the purple cone. Volume equals pi r squared h, so pi times 8 squared, which is 64, times 4 root 5. Okay, and that's going to give me, so 64 times 4 gives me 256, so this is equal to 256 pi root 5. And now let's finish it off. So what's the ratio of the volume of the smaller cube to that of the larger? So the smaller cube's here, larger cube's here, so I have 128 pi root 2 divided by 256 pi root 5. I can see right off the bat, these cancel out. 128 divided by 256 is 1/2. And the last part of this, I don't like roots in the denominator if I can avoid them, so I will multiply by the square root of 5 over the square root of 5, which will give me the square root of 10 divided by 10, which is C.